Nope. Okay. So that means we're going to skip directly to the next keynote. If Professor Harrick Vin is prepared to do that, we'll go straight into the next keynote. And Professor Harrick Vin from TCS, from Tata Consulting, is going to talk to us about how his company, similar hopefully to the talk we heard this morning from Tim, about how Microsoft is on the way to transforming their company and why and how that's going to happen. We'll hear from Professor Vin about how Tata is going to do that with their company as well.
Okay, so good morning for the last 2 minutes. My name is Harrick Vin. I'm Chief Scientist at TCS, Tata Consultancy Services. And I'm going to actually talk to you about what TCS as a company is seeing in driving enterprise cloud strategy, or what are some of the problems, challenges, opportunities that we have been seeing in getting medium to large enterprises actually embark on and execute a cloud journey. So actually Tim did a fantastic job of telling you all about basic definitions of clouds and so on. I'm just going to repeat some of that. What I want to actually mention is that when people talk about cloud, it's actually a service delivery platform that drives experience and cost. It's really not a technology, right? So that's an important thing to remember. And when you think about cloud, there are at least two different perspectives from which you can look at a cloud. There is a consumer perspective, and there is a provider perspective. And I'll tell you why both of these perspectives are actually very important for an enterprise to actually think about. So consumer perspective, cloud is basically a service that gives you all the properties that Tim talked about. Elasticity, so you can grow and shrink on demand. Usability, so essentially more or less self-service. Agility, such that you can actually accommodate these spiky behavior or rapidly introduce new services into market. And cost variabilization, essentially consumption-based pricing, right? From provider perspective, cloud essentially means high degree of efficiency. So we heard a lot about how the public cloud providers are essentially leveraging economies of scale, doing all kinds of interesting optimizations to dramatically improve the efficiency of what they can provide. And that's how they drive the cost down. So there are two interesting things. How do you actually look at technology architectures and how do you optimize them, as well as how do you actually automate the operations of a very large complex cloud. And then there are two other important properties that if you are a cloud provider, you have to actually be very careful about. One is transparency and auditability, in the sense that you need to exactly be able to know who is consuming what, which applications are consuming what resources, and all of that essentially are used to actually derive a total cost of operations, not only for you, but also what you need to charge. Now, it's interesting, why am I actually giving you both of these perspectives? As an enterprise, certainly medium to large enterprise, you will actually both be a consumer of a cloud as well as a provider of a cloud inside the enterprise. So what was mentioned earlier as a private cloud. So you need to actually understand both sides of this particular story. So that's what I'm going to do very quickly. So we'll start with the consumer perspective and talk about some of the challenges and trade-offs. So when you think about cloud, and this was once again brought up during the first keynote, is that when you think about cloud services, you can define them along two dimensions. Services dimension, or service models, as to what are you consuming. You can consume infrastructure as a service, platform as a service, application operations as a service, or software as a service, even business process as a service. So you sort of keep going up the stack from infrastructure all the way up to business process. The other dimension is the deployment, or the how dimension. How is this service being provided to you? Public, private, community, or some combination thereof, what is often referred to as hybrid. Now, there are interesting trade-offs that you actually see. Obviously, there is the cost advantage that comes from economies of scale, which we saw earlier today. There are some very interesting trade-offs when you look at different points in this two-dimensional space. So if you look at all the cloud services, you can actually, as I said, you can visualize them in this two-dimensional space. And every point in this two-dimensional space has some very interesting characteristics, constraints about when you can use them or not, as well as a variety of trade-offs. So what I'm trying to depict here is that when you go from sort of a dedicated or private cloud to public clouds to all the way to public SaaS, there are different interesting trade-offs. So as you go to the right, for example, you get much better cost variabilization. At this stage, you essentially pay on transaction basis, right? And as a result, your cost variabilization is the highest. Obviously, as you move to the left, this is fixed cost, and hence there is very little cost variabilization. But when you look at control that an enterprise has on their environment, obviously, the more to the right you go, the less control you have. And as actually this middle bar is indicating, the more to the right you go, more lock-in you have. So it's a very good example. I mean, if you are using, say, public infrastructure as a service, the hypervisor layer essentially gives you portability. So you can relatively easily move a virtual machine from one to another. But the more to the right you go, a good example is, say, Salesforce.com. Moving into Salesforce or moving out of Salesforce is actually an engineering project. It is not something that you can do on a click of a button, right? So you have to understand that there are some very interesting trade-offs that actually determine which point in this spectrum are you going to work. Now, the interesting thing is that for most enterprises, there is no one size that fits all, exactly the point that was made earlier. That within an enterprise, you have such a wide range of requirements, from commodity and nice-to-have tools to mission-critical or differentiated tools that are going to differentiate your business from others. So there is no one size that fits all. And as a result, for most enterprises, hybrid is actually the way to go. I mean, you will end up using some combination of all of these in your environment. Now, how do you actually go about deciding? And actually, there was a nice slide that was shown earlier about how Microsoft is doing it for its own internal IT. Exactly that you have to do for your own IT. And in some sense, the best way to think about this is really to think about it as a decision tree, right? You throw in the decision tree, in my picture, the filters, enterprise IT at the top, and then at each point in this filtering or decision tree, there are rules that determine what part of that estate is going to be relevant for what option that you have available, right? So obviously, there is the public and private filter, and similarly, there are going to be filters that will allow you to decide whether you are going to use SaaS model, PaaS model, infrastructure as a service model. Exactly the same idea that was discussed earlier. These are some of the considerations that are actually used by most enterprises to make these kinds of decisions. So for example, public clouds, and if you look at infrastructure as a service, are actually most desirable for workloads that have high degree of variability, right? The Walmart example that was shown earlier, where you have very high degree of variability and your peak is 10 times larger than your average, obviously you don't want to provision for the peak. And so that actually is a good example where public infrastructure as a service makes a lot of sense. Oftentimes people use bursting. So you actually run most of the time of the year inside your enterprise and then burst out for this additional capacity for a short duration and then burst back in. If you look at the SaaS models, they are actually used primarily for COTS applications, right? So with very little customization. Because anything that is SaaS, by definition, is really not going to allow you high degree of customizability at all, right? So that's sort of a standard set of things, workloads that are actually put on public cloud. When you think about private clouds, even there, there are some interesting trade-offs. See, private cloud simply means that it's actually not shared with anyone else, but it could still be provided by somebody else, right? So TCS, for example, would provide, let's say, a private cloud for you. TCS would own assets and give it to you on a consumption basis, and it's not shared with anyone. Right? So that's an example of a typical private cloud. And even there are some very interesting trade-offs that determine what goes at what level of private cloud. So for example, you look at infrastructure, platform, or SaaS models, the types of considerations that actually determine which of these things will you actually leverage are something like this. So core versus non-core services. Differentiated versus commodity services. So if it is commodity and non-differentiated or non-core, you may actually want to use a SaaS model for that, right? And if it is core or differentiated, typically you would use infrastructure as a service and actually control everything above that. We have found that the choice that you make also depends on the geography and the objective that you have. So for example, a large bank, let's say in Germany, and it's based out of Germany, may use infrastructure as a service in Germany, but if it is expanding, let's say in India, and it's actually the objective there is fast time to market, you may actually go ahead and do a SaaS model in India. And this is actually very common. So the same organization for the same application may choose two different models depending on the need. In one case, it is highly differentiated. It is actually something that you are innovating and differentiating. In the other case, you would actually use exactly the same application from a SaaS model simply because that gives you fast time to market. Right? So it's actually a non-trivial exercise to actually go through this whole process and decide on exactly what your strategy is. So the best solution to this is actually, as I said, think of it as a decision tree. So one of the things that we are doing, and I would recommend you to actually do something like this for your own sake, is, as I said, drop your entire IT and with all of its constraints and objectives and characteristics through this filtering process and then essentially determine what part of the estate actually qualifies for which particular option. The interesting thing here is that these set of rules are actually somewhat getting standardized by business domain. So if you are a retail bank, there is a reference model of what a retail bank looks like, right? So a typical retail bank will have a collection of 100, 200, 500 types of applications. And each of these applications can indeed be classified along many of these dimensions, and then it becomes relatively easy to actually understand exactly what part of your estate would qualify for what target state. So this is actually all about the consumer's view. As a consumer, as an enterprise, when you are essentially embarking on a cloud journey, you would have to essentially determine what part of your estate will you be able to use public's infrastructure, platform, or software as a service. Of course, as I said, there will be some part of your estate that will have to be managed internally using a private cloud. Now, in the design of that private cloud, essentially the objectives are efficiency, transparency, auditability, and sort of very detailed understanding of economics. Where exactly is your cost going? So given the time constraints, I'm going to actually spend most of the next maybe 5 or 10 minutes talking about, pardon me? This was 30 minutes, I thought.
We're a keynote here. This is not a lightning talk. This is the second keynote of the day, and the keynotes are 30 minutes each. Otherwise, I would have long since thrown him off. No worries.
Yeah, exactly. I would have been long gone. So we'll talk about the efficiency point. There are two interesting principles that one has to actually think about when you are designing a private cloud environment within your enterprise. The first one is the need for leveraging low-cost architectures. when you build a private cloud, you essentially have to leverage and build upon a lot of low-cost architectures. And this is indeed exactly what public cloud providers have also done. The interesting thing here is that in order to design low-cost architectures, the principle that you have to rely upon is this idea of loose coupling across layers. So if you actually look at your enterprise IT environments and you look at where the cost is going, majority of the cost goes in actually designing extremely robust, scalable systems, right? So you're building things that are actually going to tolerate variety of failures, are going to, so your clustering solutions, your load balancing solutions, your high availability and disaster recovery solutions and so on and so forth are where majority of the costs go. And the reason why that is the case is that these architectures are designed assuming that failures are bad, that failures, when they happen, there is such a high dependence on that piece of hardware or software that you have to protect against all of those failures. And then, of course, you do all sorts of interesting things to actually mask those failures, but that actually increases costs. So the low-cost architectures actually take a completely different approach and ask the question, how do I actually build my systems using commodity components and make each component completely replaceable? So if it fails, I can simply bring up that environment on a different device, whether it is compute, storage, network, whatever the case may be, right? So in some sense, the design philosophy changes from a tightly coupled, highly reliable environment to something that is actually designed to accommodate failures. And that's a fundamental philosophy that if you start applying in your environment, you'll actually come up with very interesting ideas for dramatically reducing costs. So if you actually, a good example of this is virtualization, right? Server virtualization essentially decouples what you are running inside a virtual machine from the physical hardware. So if the physical hardware fails, you simply move the virtual machine somewhere else. So and hence, by having a small number of spare blades, you essentially keep moving workload around. Problem becomes a lot simpler. So that's actually a key requirement for developing sort of efficient private cloud architectures. Exactly the same argument works for storage. Same argument works for network. And if you actually look at, there are several, if you look at the Google file system or the Hadoop file system, it's exactly going to give you a significantly low cost storage for file storage because it is actually using high degree of replication to give you the same effect. And it essentially is designed for failure rather than designed for no failures. So that's actually an interesting thing to keep in mind. The other thing that one has to do is right sizing and sharing. Obviously, when you design these private clouds, you need to make sure that you size your environment based on the usage pattern or the demand characterization such that the total resources you provision essentially is going to take advantage of statistical multiplexing of different workloads. So if you look at a typical enterprise, when you saw the sort of the sales peaking in December, there are other applications that will peak at other times of the year. So if you look at a typical large enterprise with 1,000+ applications, different applications will have peaks at different times. And that's what you have to actually understand and use that demand characterization to provision the target environment so as to minimize cost. The second part of efficiency is actually ensuring that the operations of the environment becomes highly automated or efficient. So you want to reduce the amount of labor that is actually used for running your environment. Now, automation or efficient automation, as I said, requires automation. And automation requires standardization, right? Traditionally, when people talk about standardization, they've thought about standardizing the services, right? So you will only provide x86 with Linux with this particular version of Apache or JBoss or whatever. And you basically fix what is actually exported, and you require everyone to use those standard services. The reason for doing this is that majority of the effort actually and time goes in managing heterogeneity. If you reduce the amount of heterogeneity, you obviously make the environment more and more efficient. Now, the problem with this approach is that it is generally very constraining. It limits your ability to innovate or be very agile because you cannot take advantage of a new cool technology that has actually just come, that has become available. This approach seems to work reasonably well at low levels of IT, primarily at the infrastructure level, but the moment you go higher up, this approach doesn't work. I mean, most of you, I'm sure, have seen in your own environments that driving technology stack standardization or moving out of, say, mainframe is a massive exercise. It takes years. And by the time you're done, you have created new legacy, and then you'll keep repeating this. So there is no end to this problem. And the reason why this happens is because of the fact that standardization is generally very, very hard to achieve. So there is no one standard that actually fits. So the approach that we think is actually most effective in driving efficiencies within in the design of cloud environments is actually, instead of standardizing services, standardize on knowledge, which is a completely different way of thinking about this problem. The reason why operations become inefficient or actually require a lot of people is because of the fact that today we are relying very heavily on a lot of tacit knowledge that people have about how to operate and manage either an infrastructure or an application environment. So if you want to drive efficiency, you can do one of two things, right? We can either take this approach, which says, no, 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 I will not allow all these variations. Everything is standardized, and hence I will actually, because I have to only support 2 different standards, I can automate a whole heap of this. The other approach is to say, no, 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 diversity or heterogeneity is a fact of life. Instead of actually relying on heavy degree of standardization in terms of services, let's actually standardize the knowledge that is actually used for operating the environment. The challenge, obviously, is that you have to capture, formalize, and disambiguate this tacit knowledge. How exactly is your enterprise IT and operations team running your IT today, right? Are there very good knowledge articles about exactly what are they doing? Are these articles formal enough? Are they disambiguous, meaning there aren't there ambiguities? In most cases, what you find is that, I mean, you look at most organizations, in fact, I'm yet to find an organization where this knowledge is captured very well. I mean, you'll have documents that are ambiguously written. It still relies heavily on people's tacit knowledge about exactly what to do when a particular type of an incident or a problem arises, right? So this is a key, which is that you have to be able to capture, formalize, and disambiguate this knowledge. You have to find ways of actually standardizing automation given this knowledge. And there are obviously many different technologies that are available for doing that, Arago being one key leading technology in that space. And then the last obvious challenge is, when you do this, how do you keep the knowledge current? Because applications keep changing. Yeah.
How do you get people to share the knowledge? Because knowledge keeps having their job.
Yeah. That's job security.
Can we hold the questions until the discussion panel, which is coming up just in a few minutes?
Excellent question. I will answer that later. So just a quick answer is that if you actually look at how services are actually imparted today, they are actually often divided into level 1 services, level 2 services, level 3 services. Typically, all level 1 services, which is where the bulk of services actually happen, are completely, there is a completely detailed procedure. They simply execute a procedure. So they are actually reasonably documented. As you go higher up, you're absolutely right. It becomes more and more difficult to actually externalize that knowledge. There are some interesting tools we have that actually try to automate the process of knowledge capture, but we'll not go into that for the moment. But it's extremely important to understand that that's really at the heart of the problem. The problem is designing efficient IT actually translates to doing efficient knowledge management. And it's not really about standardization of services, right? So important thing to realize, this is a huge problem. How do you actually maintain knowledge in a manner that actually remains current? Because as you can imagine, every application will go through revisions. Your technology stack goes through revisions, versions change. You have to make sure that your knowledge articles or automation essentially keeps pace with it. So the big challenge actually in this space is that when you try and automate a lot of things, you are in effect developing a large number of little applications. So by automating 10,000, 20,000, 50,000, 100,000 tasks that your level 1, level 2, level 3 teams are doing, you have in effect created a very large collection of little applications which now have to be maintained. And that's an interesting and a very difficult problem. So, but that's actually the key in order to succeed in improving operations. So let me conclude by saying there are 3 things that if I were to actually tell you that if you want to take away from this particular discussion. First, there are several business trends and strategies as well as technology trends that are actually going to force an enterprise to actually embark on and execute sort of this hybrid cloud journey. So enterprise IT must embrace what I would call the extended world. So traditionally, enterprise IT has operated in this very nice world where there was a very clear distinction between what is inside and what is outside. Right? And it's protected by nice firewalls and so on and so forth. That world is very quickly disappearing. I mean, cloud is one if you think about mobility. And mobile device usage, you look at social media, exactly the same trend. So this wall that enterprise IT had created is essentially crumbling and crumbling very fast, right? So that's the first important point to remember. Second important point to remember is that all of these technologies are changing very fast, right? And leveraging these technologies effectively inside an enterprise requires very careful engineering, without which you'll actually, I mean, it's very difficult to design these systems. So this whole decision tree that we talked about earlier for just the cloud space is actually a good example of careful engineering requirement for building an effective cloud solution for an enterprise. And the last message that I would like to leave with you is the fact that the key to success for enterprise IT environments are these 3 things. Be strategic, know exactly why you're doing what you're doing, right? Don't use technology just because it's a new buzzword in town and you want to use that technology. It never works. It's important to realize that any decision you take, especially at the infrastructure and platform level, will stay with you for many years. So you better be very careful about actually making that decision. That's number 1. Number 2, be agile. Because if you're not agile, businesses will essentially ignore you and go directly. Right? Second very important point. And the last point is be flexible, because all of these things are changing and changing rapidly. And if you're not flexible, once again, you will be extinct. So with that, I'll stop. Thank you.
Thank you, Professor Vin.